In stochastic process, there are issues or items that we need to know, and one of them is generating functions. So generating functions, they are what we call a sequence. You have to have a sequence, right? Now sequence are just numbers like this, A1, A2, right? Then from there you have series, right? So from sequence you form series, right? And particular type of series is what we call power series, right? So a power series is simply a function of this form. So you have A0, which is this sequence, you add to A1, S, right? Then you have to A2, S squared, and we put 3 dots to mean it can go on up to infinity, right? So this is a series, right? It's actually a power series, right? And the numbers, these ones are called sequence, right? So this is what are very important too. Now, we have special cases also of generating functions. And one of them, which is very important, is probability generating functions. So this is a special case of generating function where these numbers we are calling sequence, they lie between 0 and 1. The sum of these numbers here, the sum is 1. So if you have numbers which are lie between 0 and 1, and the sum of those numbers is equal to 1, right, then we have what we call a probability generating function. Right? So we say this series here, power series, is a probability generating function. Right? So, notation-wise is instead of AS, this is replaced by a notation GS. This is generating function in general, but GS now is a particular type of what? Of a power series. Right? So instead of A, we use AK or A, Now we use what? PK. P stands for probability. Yeah. So we have now what we call probability generating function, right? Now instead of A0, we have P0. That is probability when the value is 0. Then P1 is probability when the value is 1. You multiply by S. Then when the value is 2, we have P2 S squared. And you can go on like that. So we have now a generating function, we have a probability generating function. This probability generating function helps us to determine what we call in statistics mean and variance. So the mean and variance is obtained, or they are obtained by just differentiating. When you differentiate with respect, you have GS. So differentiate, this is a constant, so you have 0. So you differentiate this, you have A1. You will have this, which is this A squared. So you have 2A2S, and you can go on 3A3S squared plus whatever it is. Yeah. So when you differentiate once, you get this, then you can differentiate twice, right? When you put S equal to 1, then you get what we call the mean. So when you differentiate a probability generating function with respect to S once, and you put S equal to 1, then you get the mean. When you differentiate it twice and put S equal to 1, then you get what we call variance. So, in short, what I'm saying, the EX, which is the mean, right, this is equal to differentiating with respect to S, and then you put S equal to 1. This is how we define a mean. Now, when you have a variance, right, so you differentiate this twice, so you put the two notations this, then you put 1, plus another notation once, then you subtract, that's twice. So these are formulae for obtaining mean and variance, right? So these are useful, right? When you have some data, you want to get the mean of that data set, and you want to get the variance, so you can use the probability generating function to obtain these, what we call them generally, we call them moments. But this particular moment is called mean, and this one is called variance. You can get the mean and variance, so you can get probability generating function, you can get the mean, you can get the variance for what we call discrete distributions. So discrete distributions are things like we have Bernoulli, what we call Bernoulli distribution, what we call binomial distribution, what we call geometric distribution, what we call negative binomial distribution. So there is Poisson, and we have what we call uniform distributions. For each case, we can get probability generating function, we can get the mean, we can get the variance. So we can get the PGF, the mean and the variance of Bernoulli, of binomial, of geometric, of negative binomial, Poisson, and uniform. There are other discrete distributions, or they are called the zero truncated distributions. So where we don't have the zero, the value of zero. Yeah. So with this, you can also get the same thing. You can also get the PGF, their PGFs. You can get their means, and you can get their variances. What happens is that if I'm given a sequence, get the probability generating function, which we write in short PGF. This means probability generating function. So there are some cases where you are given the probability generating function, then you may want to know the sequence. But the other case where you are given the sequence, how do you obtain the probability generating functions? You have a sequence 1 and 1 and 1 and 1. You have A0 is equal to 1, A1 is equal to 1, A2 is equal to 1, A3 is equal to 1. So generating function, we shall just denote it by AS. And we had said it was A0 plus A1S plus A2S squared plus A3S cubed, in this case here. So A0 is 1 plus 1 times S plus 1 times S squared plus 1 times S cubed. So which is equal to just 1 plus S squared plus S cubed, right? Yeah. So this is generating function. Now we can put it in a short form, right? How do we put short form? So to get the short form, or well, to know whether it is what we call convergent, it is summable. So what you do is you multiply this S by AS. So if you multiply, so this 1 times S is S times S is S squared. You are multiplying everything by S. This is S what? Cubed plus S fourth. Yeah. So if you subtract these two, so that you have got AS minus S. So you are subtracting. So you are subtracting this. So this is 1. S and this, they cancel. This and this will cancel. This and this will cancel. This and this will cancel. So what will remain is this, which is minus S what to the power 4. So AS is common. So 1 minus S. AS is common, so you have what? 1 minus S to the power 4. So what is AS is just 1 minus S to the power 4 over 1 minus S. So in other words, what we are saying is that 1, this AS, let me put in 1 plus S cubed is equal to 1 minus S to the power 4 over 1 minus S, so long as S is not equal to what? 1. Because if S equal to 1, this will be 0, right? Yeah. So in other words, we have, so this we say If given a sequence 1, 1, 1, 1, the generating function is this. So here you are given a sequence, here is the generating function. So we talk of, in mathematics, we talk of a function. If you have any function, right, and this function is denoted by a notation like that, fx, right? If you have a function like that and which satisfies the following two conditions, right? The following two conditions. So one is that this function here, so function is just a number, so which lies between 0 and 1, right? The other condition is that when you sum, summation is given by this notation, you sum over x, right, equal to 1, which is called a probability mass function, or we just call it PMF. Now the other condition is that this function, right, instead of summing, you are integrating. The other definition is if fx is a number greater or equal to 0, right, and if you integrate to get equal to 1, then this function is called probability density function. So we have got two types of distributions. We call this distribution. There's what we call the probability mass function, that's called discrete. So you are dealing with numbers. If a value x is 1, it is 2, right? So you have what we call probability mass function. Or you have probability density function, when the variable is any number. It can be 0, 1, 1.5, 1.1, and so on, right? So you have two types of distributions which we call discrete and what we call what? Continuous. Example I gave earlier was discrete, like Bernoulli was a discrete, binomial was discrete, we have Poisson, right, and so on, right? So these ones, there are things like what we call exponential, we have what we call gamma, Pareto. So let me give an example of what an exponential looks like. For example, exponential is something like e, like this, something like that, x. So lambda will be some value, let's say 1 or 2, right? And then x, if x is 0, if x is 2, if x is whatever it is. Now, these distributions are what is used in Safaricom or Airtel, whatever it is. So what you mean as a mathematician, I can give Safaricom use Pareto distribution, right? I give, what's this, orange gamma distribution, right? So he can generate, because all he needs is to put, so this will be a value, let's say 2, E2. So all you need is to put x here. So when x is 0, you get a number. If x is 1, you get a number. X, yeah. So you have those numbers, and those numbers are what you are buying, and you call them scratch cards.